Hi guys, welcome to lecture number 7. So guys, today on in our NLP series we'll be discussing firstly general context training, and then we'll be talking a bit about logistic regression. As I've been saying guys, that we need to quickly move to a stage that you start using LLMs specifically for NLP based workloads, and we are in the right direction. But guys, these sort of basics are important since these will help you understand things better and also give you a good understanding on how to evaluate your interviews and other types of stuff. So guys, see, if you're new to it, just I'm going to give you some intuition. What is machine learning? So first of all, let's just talk about logistic regression. So what is logistic regression, and like why I'm talking in terms, so it is a machine learning algorithm. Okay, the main context of all machine learning algorithms is that it needs to learn what it needs to learn, guys. It needs to learn optimal value of parameters. Okay, how does it finds out the optimal value of parameters? For the time being, let's just stick to gradient descent. Okay, gradient descent, just check the spelling, but it's fine. Okay, so the main context is that we have these equations: w new is equal to w old minus learning rate of change of loss function with respect to w old, and okay, this equation is okay for the timing. So guys, in every algorithm, okay, in every algorithm you would find that there are few weights. These are essentially called as parameters. We need to find their value so that we can come up with an equation that can help us, okay, that can help us in predicting stuff in at a very high level. Okay, so what all we need, so first of all we need a way we can compute its method. So I've told you that, hey, gradient descent is an algorithm that helps us compute the optimal value of these type of weights and everything. So essentially weights are nothing but parameters. Okay, so then we have something known as learning rate. We'll see that ahead. So essentially for the time being, you can consider learning rate as a hyperparameter. So hyperparameter is something that you set in the runtime, which is also okay. Now l- let's just talk in general terms. Okay, let's just talk in general terms that what happens is that we have a loss function. So whenever we are doing any task, so for NLP, we mostly like do classification. So for classification, let's say you are doing an NLP classification using logistic regression. Okay, so you would have a loss function. Why do we need a loss function? Because guys, as I said, that in gradient descent, an optimal value of parameters is computed using this equation. But if you would see that there is something known as L. Okay, so what is this L? This L is essentially your loss function. So what happens is, let's consider, I'm just giving you an example of how this works. Let's consider you are having linear regression. That's the most basic thing that we can talk about. And what is the loss function that comes up there? The loss function is 1 by n, 1 to n y hat minus, okay, it's because I haven't like prepared these notes, I'm writing whatever is in their mind, in my mind. So yeah, this is the loss function. So what is the this with respect to, let's say, w, or perhaps let's just say with respect to x. So what is y hat, guys? Isn't y hat xb plus c? Okay, so let's just try to put in those things. So guys, this is linear regression. If you don't understand, it's okay, but essentially it's good to know. But mostly, as I said, that this is a beginners friendly course and I would focus a lot on LLM based development. That's what it is used in the industry. So but still, just for some context level understanding, you can skip this part or you can stay. So rate of change of loss with respect to x would be, okay, first of all this 2 will come over here, 1 by n y minus xb c into minus x. So guys, see how I was able to compute its derivative. So this is what happens in back propagation. That we compute derivatives. Okay, we compute derivatives, we compute partial derivatives, and then we try to plug in into this equation. Obviously guys, this is the basic equation of gradient descent. Okay, where is that equation? That's there. So we try to plug in the stuff over here, and then it just happens. Obviously then we use gradient descent with some sort of optimization as well. I'll explain you all those things as and when they are required, but you just need to understand that what happens at a high level first. So at an high level, the things are simple. You need to compute parameters. Okay, then you need to understand that, hey, I'm going to compute those type of parameters, and then how will I compute it? For this I'll use gradient descent. I need a loss function as well for my problem statement. Okay, so there are different types of loss functions, like I shown you one for regression, for logistic regression. We'll talk about logistic regression as well. There is another loss function, that's cross entropy loss. I'll show you, don't worry. But at a high level guys, this is what happens, is that you need to compute the value of parameters. We do it using gradient descent. You need a loss function which is derivable. Okay, because essentially, as I shown you, right, in gradient descent we have a thing called rate of change of loss with respect to w old. So essentially, if your loss function is not derivable, it won't work out, and then you move ahead, right? So let's just spend some time to understand logistic regression. So guys, there is something known as the sigmoid function. First of all guys, logistic regression is nothing, it is a classification algorithm. Okay, classification algorithm. So it helps you classify, let's say, positive, negative reviews. Okay, spam, ham, we have talked about these things a lot, so I don't want to spend a lot of time, and we need to quickly ace up our pace so that we can match the pace of development, but we'll do it slowly, don't worry. And now the main thing guys that we need to understand is that what happens in logistic regression is that there is something known as the sigmoid function. Just try to see its graph. So we have a thing called sigmoid function. So what is essentially z is equal to wx plus b, and then we can plug in, that's okay. It will become like this. So guys, what is exactly happening in logistic regression? Let me explain you why we need to think more about sigmoid function and try to understand it. Let's just try to get here. So let's just try to get over here. How does logistic regression work? So guys, inside logistic regression, what we have is, let's start with the equation z is equal to wx plus p. Now this is the basic equation. What is x over here? X is considered as training data. Now the thing is, you need to compute the optimal value of w and b, because these are your parameters. Now the next thing that comes up here is that how do we calculate it? So we need to calculate it using gradient descent. Okay, now the thing is, what happens in logistic regression is that this can be then like wx plus b. Some people also write it like this. If you'll see over here how they have written it, like this, and then this summation gets converted into dot product, which is okay. So we have z is equal to this. Now the thing is, what usually happens in logistic regression is that you have, for binary things, you have two classes, positive and negative. So as I have taught you in the previous lecture, that logistic regression is nothing but it is a discriminant classifier, not a generative one. Okay, it's not a generative one. So what it will do is, it will compute the probability of occurrence of class positive or class negative. So for a binary classification, this would equal to 1. So guys, for it to convert it into a probability form, right? Because essentially we need to convert it into a probability form. So we usually start with this thing, z is equal to wx plus b. Okay, number one. Number two, we just split it out like this, w1 x1 w2 x2 so on plus b. Then we compute the value of these things. Okay, how do we compute the value of these things? By gradient descent. What happens in gradient descent is optimization happens. We'll talk about that in a separate lecture, but still the main idea is that it's an algorithm that helps you compute optimal value of parameters. What are the parameters over here? W and B. Then since we need to talk about logistic regression and what is the probability of occurrence of a class, we need to squash this. So how do we squash this? We squash this using sigmoid function. So what is sigmoid function? Sigmoid function is 1 plus e to the power of minus z. So if you'll see its chart as well, there they have given their chart as well. So yeah, you can have a look at it. You always takes value from 0 to 1. Probability also always takes value from 0 to 1. So 1 plus e to the power minus wx plus b. Why? Because z is essentially that. So you can even just understand this, that this is the main thing, what happens at the core of it. So this was more like an mathematical intuition, and the loss function involved in logistic regression is cross entropy loss. Let me show you the equation of there. Cross entropy loss function, let me show you. This is the equation for cross entropy loss function. So guys, main thing for this lecture that you need to understand is that what we talked about today is essentially two things. One is general purpose, and then we gave the example of logistic regression. General purpose, so, and then logistic regression. Let's just try to combine everything whatever we have done, and I'm sure you will be able to get it. So guys, usually you have training data. So you have training data, that is essentially your past data. So you need to first of all fit it in an equation. For logistic regression, as I said, that z is equal to nothing but wx plus b, and then you take the sigmoid of it. Essentially that just gives you 1 plus e to the power minus wx plus b. Okay, we take this thing and we just try to compute the value of w's and b with the help of gradient descent. So whenever you have training data, you need to fit these things into an equation, and for those things you need to compute value of parameters. How do you compute the value of parameters? You do it using gradient descent. And then specifically for logistic regression, for gradient descent you require a loss function as well, because there is an element of loss function as well in the derivation. So what is loss function? Is exactly nothing but loss function is the cost function, or perhaps the function that you wish to optimize. So in order to find optimal values for parameters, you would need a function, okay, that you would optimize. So for linear regression we have this something like this, 1 upon n, something like this. Okay, for logistic regression I showed you we have cross entropy loss. So guys, all these loss functions, okay, these are mainly derivable, because we need to take their derivatives in order to find the optimal value of parameters, and then we just have those optimal values of parameters, then we can test it. So guys, mainly this is the process that happens in training of a model. Okay, training of a model is simple. I'll write over here, you have data, you need to fit in some sort of equation. To get that sort of equation, you need parameters. For parameters, you need gradient descent. For gradient descent, you need loss function, and loss function is more like for classification, you will have separate loss function, and for regression, you will have separate loss function. So guys, this is okay. If you don't want to go through maths and all, that is absolutely fine, of how the partial derivatives and everything are computed. I just gave you a high level overview of how exactly things happens, specifically in terms of workflow, which is more important to understand. And if you guys feel that there is too much maths in this lecture, you can skip, because essentially guys, we need to switch towards LLMs as well. And as a developer, you don't luckily need to know a lot of maths, but it's good to know all these things. If you want to skip it, you can. I have no issues. We'll meet in the lecture 8. And guys, these initial lectures might have some sort of maths, because I want to make a full-fledged playlist, but post that, it's okay. We won't be spending a lot of time on there. And this would be an end-to-end playlist, guys, so I need to cover both aspects. But we'll very soon start with development, so that we can easily ace any NLP interview. Thank you, guys.